Elastic collision. So we've looked at inelastic collisions and recoil. Now we're going to look at elastic collisions. So in elastic collisions, it's important to remember that each object will always has its own separate mass and its own separate velocity. So they start out separately, m1, v1, they have their own velocities, plus m2, v2 will equal their combined velocities and times mass afterwards. So remember, sometimes it really is helpful if you color code these just to keep things clear in your mind. So here's an example. I have a 0.5 kilogram billiard ball with a velocity of 4 meters per second, and it hits a 0.25 kilogram golf ball at rest and continues to move forward with a velocity of 3 meters per second. What is the velocity of the golf ball? So there's a couple of clues that this is an elastic collision. One, they each have their own velocities, right? So the first one has a velocity of 4 meters per second, and the second one's at rest. Then after the collision, right, after it hits, continues to move forward with a velocity of 3 meters per second, and we're asking you what the velocity of the golf ball is. So it's not the same, they're not together. And it says continues to move forward. There's no mention that they stick together or they crumble or whatever. So these are the clues that we're looking at an elastic collision. So I set it up, m1 v1 plus m2 v2 before is equal to m1 v1 plus m2 v2 after the collision. And I'm looking for the velocity of the ball, the second one. So I solve for v2. So first I subtract m1 v1 from both sides, and I get m1 v1 plus m2 v2 before the collision minus m1 v1 after the collision is equal to m2 v2. Now it's really important to remember that this is not going to be the same number as this. Just because it's m1 and v1 here, that's pink, and pink is for before the collision, and m1 v1 is after the collision, right? So they have separate velocities, so they're not going to have the same momentum. Continue solving. I divide both sides by m2, and now I have v2 by itself. So now that I have v2 by itself, the after collision v2, I then plug in my numbers. 0.5 is my m1. Its velocity at the beginning was 4 meters per second. This is the mass of the second object, and it was at rest, which means 0 meters per second. The mass of my billiard ball stays the same, but it has a velocity of 3 meters per second now, and the mass of my golf ball stays the same. So now I plug the numbers in, and I end up with a velocity of 2 meters per second. So what's happened is that this has hit this ball here, it was at rest, and now they're both moving forward. This one has a larger vector, this one has a smaller vector, right? So it gave some of its velocity to the ball at rest. You can have another situation in which they're both moving, right? Here's an example in which they're moving in opposite directions. So if you're looking at the picture down here, I have a small ball moving this way and then a large ball moving this way, and then trying to figure out what's going to happen. So the example is a 0.4 kilogram baseball with a velocity of 30 meters per second is hit by a 1 kilogram bat that's swinging in the opposite direction with a velocity of negative 18 meters per second. Well, it doesn't say 18, it just says at 18 meters per second. So this is my before, circled in pink, and opposite direction is telling me that I've got to put a negative in there just for my future self. It will probably not say that in the problem, just saying opposite direction and this is speed, I got to add negative sign to show the direction to make it velocity. So you know with baseball that the ball is not going to stick to the bat, right? So if the bat slows to a velocity of 4 meters, negative 4 meters per second, 4 meters per second after hitting, what's the velocity of the baseball, right? So again, they both have a different velocity. I'm looking for the velocity of the baseball, and I gave you the velocity of the bat. So that tells you that's an inelastic collision, even an elastic collision, even if you don't know anything about baseball. So this is my general format. Right now I'm solving for V1, the velocity of my baseball. So I subtract m2, v2 from both sides. That's the new one again. So it's not the same thing as this, it's green. And then I divide both sides by m1. And then I add in the numbers, remembering that the bat is always having a negative velocity. And then I solve, and I find out that baseball now has a negative velocity, which makes sense, right? The baseball is coming in, the bat hits it, and it reverses the direction, and now the velocity of the baseball is in the same direction as the velocity of the bat. So it's a negative velocity, and it's negative 10 meters per second. So I had this small object with a high velocity hitting a large object with a smaller velocity in the opposite direction. But the momentum of this was enough to change this direction of the ball to the opposite direction. Now, that's what bat speed's all about, right? So if my bat speed is even higher, it starts out higher, then what's going to happen is that I'm going to be able to change that velocity even more. And so I'll be able to get that baseball out farther. So another thing that athletes work on is increasing the speed of their swing, of their bat or whatever, so that they're able to actually propel whatever it is that they're trying to propel farther, faster, all of that stuff, right? So it's the difference between kicking a ball with like a kind of slow kick versus like really winding up and accelerating your foot really quickly. Again, it's all physics.